everyone, welcome back to my YouTube channel. So today we are going to solve day 1 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with the today's problem. Problem number 2141. Maximum running time of n computers. So let's make this problem easy. So in this problem, you have n computers, right? And you are given the integer n, right? And a zero indexed integer array batteries where the ith battery can run a computer for batteries of I minutes, right? You are interested in running all the n computers simultaneously using the given batteries, right? So here if you see example number 1, so n is equal to 2 means we have two computers, right? And batteries, if you see the length is total 3, right? Length of this, so we have 3 batteries, right? And the charging in these 3 batteries, if you see, it's 3, right? 3 and 3, right? So charging scheme it was, right? All right, so what you need to do, so initially you can insert at most one battery into each computer, right? At most one battery, right, into each computer. After that, and at any integer time moment, you can remove a battery from a computer and insert another battery any number of times, right? And the inserted battery can be a totally new battery or a battery from another computer, right? You may assume that the removing and inserting processes take no time. Okay, so we will understand this line, right? So here if you see, these are the batteries, right? So initially let's say this A battery, this is battery B, so this is battery C. So here initially see, uh, let's say this is computer C1, computer C2, right? So using A battery I am charging computer 1, using B battery I am charging computer 2, right? Done. So this 1 minute is done. Okay, so here let's say 1 minute is done, right? And then after that let's say one more minute is done, so in total let's say 2 minutes are done. So after 2 minutes what will happen? Charging of this will be 3 minus 1, 3 minus 2, right? After 2 minutes I'm checking, so it will be 1, right? A charging of B is also 1, right? Because I was using this battery only, battery B, right? And charging C is full right now. Okay, so now after that what I do after 2 minutes, right? So now I plan to use battery A for C1, and instead of battery B for C2, this time I plan to use battery C for C2, right? So again 1 minute is passed, again 1 minute is passed. So again if you see here I'm using new battery, right? Here I'm using new battery, if you notice, right, for C2 computer. Now after 1 minute what will happen? This A, right, this battery A is going to be reduced to 0, right? B is still 1, B is still 1, right, after 1 minute. And now C will become 2, right? C is going to become 2, right? Now again if you see, this is the used battery, this is a used battery, right? Here if you see, this battery is used by C2. Now I'm going to use this battery for C1, and I'm going to use this battery C for C2, right? Then again after 1 minute what will happen? This is going to become 0, this is going to become 0, and this is going to become 1, right? A B C, right? Now at this point of time I can charge this, but how I'm going to charge this, right? It is not possible. So if I'm not able to charge all the computers, right, at a time, I have to stop, right? So here if you notice, so total time consumed is 2 minutes, 1 minute and 1 minute, total 4, right? So this is what we need to do, right? So no, here also note that the batteries cannot be recharged, and what we have to return, we have to return the maximum number of minutes you can run all the n computers simultaneously, right? So that is why we are getting the output as 4 here. Okay, and these are the constants. So batteries dot length from 1 to 10 raised to power 5, and batteries of I value is from 1 to 10 raised to power 9. All right. Okay. So here, if you notice, right? So what we are doing? We have n computers, right? And we have one zero indexed integer array batteries where the ith battery can run a computer for battery of 5 minutes, right? This we know, right? And we are only interested in running all the n computers simultaneously, right? So if both computers are running, then it's fine. But if anyone stops, then we have to just halt the complete process. We have to stop the complete process, right? And you can insert at most one battery only into each computer, right? And when we are going to change the batteries, right, we can insert a battery, totally new battery we can insert, or we can use a battery from another computer, right? So this process is not going to take any time. You may assume that removing and inserting the process take no time, right? This is given to us, right? Clear? And here you can remove a battery from a computer and insert another battery any number of times. This is also given to us, right? So I hope that now problem statement is clear, right? What we need to do, right? Okay, so here if you want, you can go over this explanation. So initially insert battery 0, right, 0 into the first computer, and battery 1 into the second computer, battery 1 into the second computer. After 2 minutes, remove battery 1 from the second computer and insert battery 2 instead. Note that battery 1 can still run for 1 minute, right? At the end of the third minute, battery 0 is drained and you need to remove it from the first computer and insert battery 1 instead, right? And by the end of fourth minute, battery 1 is also drained and the first computer is no longer running, right? We can run two computers simultaneously for at most 4 minutes, so we run 4. That's it, right? So here let's go over this example too quickly. So n is equal to 2, so two computers we have, C1 and C2, right? And we have 4 batteries, right? So let's say A battery, B battery, C battery, D battery, right? So in 1 minute, let's say I use this and this, right? So both are going to become 0, right? A and C both are becoming 0, right? So 1 minute is passed. Now in the next minute I plan to use B and D. So again 1 minute passed and now all batteries are drained, right? 0. So now no, these two computers are not running simultaneously, right? These two or these n computers you can say, right? So we have to stop. So how many times they are running simultaneously? 2 minutes. So output is 2. That's it, right? So now how I'm going to solve this problem, let's see. So let's take this same example. N is equal to 2 and batteries is equal to 333, right? So n is equal to 2 and batteries is equal to 3 comma 3 comma 3, right? Now here n is equal to 2 means we have two computers, C1 and C2, right? So first at time is equal to 1 minute, right? So at time is equal to 1 minute. So let's say my C1 is using this, my C2 is using this. So at time t is equal to 1 minute, what is going to happen? This is going to 2, this is going to become 2, right? And then this is going to remain 3, right? Clear? And then time, let's suppose now time becomes 2 minutes and I'm still using this C1 and C2, right? So here this is going to become 1, this is going to become 1, and this is going to become 3. Okay, now let's suppose I plan to use this one C1 and this one as C2, right? So now at time t is equal to 3 minutes, what is going to happen? This battery is going to become 0, this is going to become 0, and this is going to remain 3, right? Now again here if you see, I have to run two computers, right? C1 and C2, right? So let's suppose if I plug C1 here, but where I am going to plug C2 now? Here it is already 0, here it is already 0, so it is not possible. So here only 3 minutes I'm getting, but my output is not 3 minutes, my output is 4 minutes, right? My output is 4 minutes, it's not 3 minutes, right? Why? Because we need to return the best, we need to return the maximum number of minutes you can run all the n computers simultaneously. So how we are going to do that? So here I have to change a little bit, right? So again let me write it here. So now what I'm going to do, C1 and C2 you have, right? So at t is equal to 1 minute, right? So let's say you are using this same C1 and C2 initially, right? So what I'm going to get, I'm going to get 2 comma 2 comma 3, right? So this is the same case as this one, right? Same case as this one, right? Now let's say here for the next time t is equal to 2 minutes, right? As soon as 2 minutes passed, so let's say I was using this as C1 and I was using this as C2, right? So now it is going to become 1 1 and 3. Now here at t is equal to 2 minutes, I was taking this as C1 and I was taking this as C2. Now what I'm going to do, I'm going to take this as C1 and I'm planning to take this as C2, right? Now at t is equal to 3 minutes, what is going to happen? This is going to become 0, this is going to remain 1, and this is going to become 2. Now here at t is equal to 4 minutes, what is going to happen? Let's say I plan to use this as C1 and I plan to use this as C2, right? So now this is going to become 0 and this is going to become 1, right? So now in this case, see, Now here I can use this as C1. Let's say I use this as C1, but where I'm going to print C2, right? So I have to hold the process, right? Because only one computer I can charge, right? But here until 4 minutes we are able to do this, right? So here 4 is the best answer for this example, right? So instead of 3 we have to return 4, right? So I hope that this part is clear why we are returning 4, right? Okay, now how we are trying to do this? Next question, how we are trying to do this, right? So here same example, let's say same example. So n is equal to 2 and batteries is equal to 3 comma 3 comma 3. Okay, so here first of all add t is equal to 1, right? So during 1 minute can my both the computer C1 and C2 be happy during 1 minute, right? Can they be charged simultaneously or not at t is equal to 1? So see here this is 3, right? So here definitely my C1 is happy, let's say, right? Here also this is 3, right? So let's say my C2 is also happy, right? So it is possible, right? So with t is equal to 1 answer is possible, right? With t is equal to 1 answer is possible. And even if you see this one is also capable of charging the computer in 1 second, right? So all these three batteries are capable, right, at t is equal to 1 minute, right? So here all these batteries are good, right? Initially all the batteries are good. Now at t is equal to 2, let's say. So here this battery is capable, okay, of charging any computer for t is equal to 2 minutes, right? This battery is capable, happy, right? This battery is also capable of charging any computer for t is equal to 2 minutes, right? Happy. This battery is also capable of charging any computer for t is equal to 2 minutes, happy, right? Clear. Now at t is equal to 3, at t is equal to 3, all three batteries are capable of charging any computer for 3 minutes. So all are good, all are good. Clear. Okay, now there is one twist. At t is equal to 4, at t is equal to 4, this battery is only capable of charging for 3 minutes, not 4, right? So I'm this is nothing but I'm thinking of answer, right? Maybe with one answer is possible, maybe with the two answer is possible, maybe with the three answer is possible, maybe with the four answer is possible. But here if you see unhappy, right? Unhappy, right? Because only three I can do, right? Not four. Here also it is unhappy, right? Because only three I can do, not four. Here also it is not happy because only three I can do, right? For 3 minutes I can charge, not four, right? So all are unhappy. But here with t is equal to 4 answer is possible. With t is equal to 4 answer is possible. Why? Right. Let's see. So here if you take two computers C1 and C2, right, and I am saying t is equal to 4, right? So that simply means 4 minutes for this one, 4 minutes for this one, right? This is what I'm saying. So in total how many minutes I'm talking about here? 8 minutes, right? If for t is equal to 4 I am saying that answer is possible, right? Because I know answer is possible for this example with t is equal to 4, right? That simply means that I am capable of charging computer C1 for 4 minutes and I am capable of charging computer C2 for 4 minutes, right? I am capable of this. But here if you see all are unhappy. Okay, okay, you guys are unhappy, but tell me why. So he is going to say that he can charge only for 3 minutes. He is going to say that he can only charge for 3 minutes. He is going to say that he is only charged for 3 minutes. Okay, you guys can charge for 3 minutes, you can charge for 3 minutes, you can charge for 3 minutes. So tell me now how much charge you can do in total. So they are going to say that we can do 9 minutes of charging in total, right? 3 plus 3 plus 3, 9 minutes of charging in total. So now if I'm capable of charging for 9 minutes in total, right, with all these batteries, then definitely this answer is possible, right? Then definitely this answer is possible because I can do the switch, right? I can do the switch, right? So maybe what I can plan to do, maybe I can do like this, okay? uh, C1 and C2, right? So initially let's say I use initially we have something like this, say 3 3, right? So initially let's say I use 1 1 from here, so it is going to become 2 2, then 3. Then initially I use 1 1 from here, so it is going to become 1 1 3. Then initially after that I use this So it is going to become 0, it is going to become 1, it is going to become 2, right? So and after that it is going to become 0, it is going to become 0, it is going to become 1. So here see, so from this side, that simply means from this side, if you notice, I consumed all three, right? And from this side also I consumed all three, and for this side I consumed 2 only, right? Because in the end I'm left with the 1, right? So I consumed 2. So see here, 3 plus 3 plus 2, 8, right? So answer is possible, right? This 8 minute like this, right? So this bit is possible. But can this is possible C1 and C2 both for 5 minutes, right? 5 minutes and 5 minutes, that simply means I'm saying for t is equal to 5. So t is equal to 5, that simply means total 10 minutes, right? So this is not possible. The reason is because if you do the total overall for all these batteries, if you do the total overall, so you are going to get 9 minutes only, right? So definitely we can never form this 10 minute, right? So we have to stop here. So this is how I'm checking here, right? So this is nothing but my linear type of searching, right? T is equal to 1 I'm searching, then t is equal to 2, then t is equal to 3, then t is equal to 4, then that's it, right? So I can further simplify this process, right? I can further simplify this process, but from here you guys are clear, right? So this itself is not possible, right? 10 minutes it is crossing the overall sum, so this is not possible. So until t is equal to 4 only I need to check, right? So only until here I need to check, right? Okay, so now here what I can do, so I'm searching on based on this answer only na, maybe 1 with 3 with 4 with 5, like this answer is possible. So I can do one thing na, this is the answer and on answer I'm searching, so I can apply the binary search on answer actually, right? So binary search I can apply on the answer because I can easily find out the values, right? So let's say if with the 5 answer is not possible, right? So I have to check in this side, that is my this side, okay? But if with the 5 answer is possible, then I have to check for some max other t value, right? Bigger t value than this side, right? So this is how binary search works, right? So we have some range like this low and high, and we have some mid value. So we calculate if our answer exists in this side on this side, right? So if my answer with this mid is possible, then maybe we try searching this side. So then after that we see if answer is here. So if it is here, then we are searching this. So this is shortcut, right? We can apply binary search on the answer, right? So now let's try to do that. Okay, so in binary search what you do, so you have to take one left pointer, right? And then you have to take one right pointer, right? So left you can take this as 0, and right you can take it as what is the max value, right? What is the max value here? Let's see. So if you see here, max value is batteries of I, right? Batteries of I value is from 1 to 10 raised to 9. So 10 raised to 9 is the max value, right? So you can take this, but actually we don't need to take such bigger values, right? We can further simplify it, right? So right, what we can take, right? So here if you see the same example, right? This same example. So if you let's say left is 0, right? Right you can take as max value. So what is the overall sum of this? Overall sum is of this is 9. So 9, how many number of computers you have? 9 divided by n. So you are going to get 9 divided by 2, that is nothing but 4. So here if you see, this is the range, right? Definitely out of this range you will never find any better value, right? So in this range only actually you need to check. So you can take your left as 0 and right as total sum, right, divided by n, total sum divided by n, right? This is what you can do, right? Okay, now once this is done, right, then after that what you need to do, right? So how we write the code for this binary search, right? So let's take one example. Can I take, let's take same example, okay? N is equal to 2 and your batteries is 3 comma 3 comma 3, right? So here from this case you can take, let's say left is equal to 0, right is equal to sum divided by n, that is 4. You can also take your L value as 3 if you want, right? Because minimum value among them is 3, so definitely at t is equal to 3, right, minimum value is 3, right? Minimum value is 3, so definitely until 3 we can charge both the computers, right? Minimum value is this, right? This is given to us, right? Okay, and here constants is nothing but, if you see, uh, n value is less than equal to battery's total length, right? And is less than equal to 10 to 5, right? So the n value, right, n value, it is always going to be less than or equal to battery's total length, right? So if that is the case, so I can easily say, now it's not like if n is equal to 2 and only 3 is given, right? It's not like this. This is not the case. So n value is always less than equal to battery's total length, right? So this value, right, this length of this one is always going to be equal to this n or greater than n, right? This is the meaning. Okay, so if the minimum value is 3, so definitely I can charge both the computers for minimum of 3, right? So you can take L is equal to 3 also initially, right? It's your choice if you want to take it like this. Okay, and if, okay, let's do one thing now. Let's take it 3, right? Why ignore it? Okay, because I was first, we can also take a 0, right? No problem. But if you further want to shorten this, you can take the minimum, no issues. Okay, let's take the minimum. Okay, let's try this way then. All right, so now what you need to do, so here, how you do the binary search, you have to run one while loop, right? While left is less than equal to right, this is how you write, right? And inside this, right? So here you have to calculate the mid, right? How you calculate the mid value? So mid value, you can calculate it like this: left plus right minus left by 2, like this you can write. Now why I'm writing like this, right? If I just simplify it, now this is nothing but, if I just solve this equation, 2 left plus right minus left by 2, right? 2 left minus left is nothing but left plus right by 2, right? So can I simply write it like this? I can, but if my left and r value are very big, right, I may get overflow error if I'm doing the addition, right? So in order to avoid that, I'm trying to write it like this, right? So that I will get always some smaller value, right? Okay, so this is the case, right? Now if here I'm going to check if with this answer is possible, if with this answer is possible, right? Then in that case, my left I'm going to update it as mid plus 1. Okay, and else if with this answer is not possible, then I'm going to update my right is equal to mid minus 1, and in the end here I'm just going to return my right. Why I'm returning right? So if my answer is possible, then what I'm doing mid plus 1, right, every time, right? Next time if my answer is not possible, so I'm simply doing the mid minus 1, so that simply means I'm going to get the previous result. Let me explain, let me give the example. Okay, let me give you the example, same example. Okay, so L is equal to 3, R is equal to 4. So what I'm going to get here, 3 plus 4 divided by 2 is nothing but 7 by 2 is nothing but 3, right? So with the 3 also, I'm going to check if answer is possible. So with the 3 answer is possible, this is very clear to you guys, right? With 3 answer is possible, right? So 3 to 4 I'm checking, right? I am going to, this is my left, this is my right, my mid is also coming it at 3 only, right? So with this answer is possible. Now next time what I'm going to do, answer is possible, right? Next time I'm updating my L as mid plus 1. So L is going to be, for the next iteration, my L is going to be at same R, right, at 4 only, right, for the next iteration, because my left is equal to right. So still answer is possible, right? Now again I go inside this mid, I calculate the mid. So mid 4 plus 4 divided by 2, a divided by 2, you're going to get 4. Answer is possible. Okay, with the 4 with the 4 answer is possible. We know that, right? We know that for with the 4 answers is possible, right? So let's say this if condition executed. Now next time my L is equal to mid plus 1, right? L is equal to mid plus 1, right? So now L is equal to mid plus 1. So your L is going to be at 5 now, right? But here 5 is less than equal to right, so we have to stop it. And in the end, what is my right? My right is 4 only, that, so that's why I'm returning right 4. Okay, clear. Let's take few more examples. let's say n is equal to 2 and we have 9 comma 1. Okay, now in this case, what you are going to do, let's see that. Okay, so here first tell me how many answers is possible right here. For this one, what is going to the answer, let's see that. Okay, c1 and c2, right? So it is going to become 8, right? And it is going to become 0. That's it. So I think t is equal to 1 is the answer for this one, right? I don't see any other answer, okay, for this one, right? So now here in this case, how you are going to apply the binary search. So low is going to be 1, right, the smaller value, and high is going to be 9 plus 1 divided by 2. 10 divided by 2 is going to be 5. Okay, 5. Okay, this is your right. Right is good 5. Okay, now first thing you have to calculate the mid. Mid is nothing but you will get 3. 5 plus 1 divided by 2 is 3. Okay, now with 3 answer is not possible. Definitely answer is not possible. So next time I am saying your L is going to remain 1, but your R is going to be my mid minus 1. Mid minus 1. Okay, so mid minus 1 is 2, right? So here R is at 2, right? R is equal to 2, right? So here L is equal to 1, R is equal to 5. Now my L is equal to 1 and R is equal to 2. Now again mid, 3 divided by 2 is 1, right? So mid is going to exist here. Okay, so with the mid is equal to 1, answer is possible, right? If answer is possible, then your L is going to be incremented, right? Mid plus 1, right? And R is going to remain 2, right? So L and R. Okay, now with the two answers is possible or not? So with the two answer is not possible, right? Right, with two answer is not possible, right? Okay, so now you are going to get mid as here only, right? So with the two answers is not possible. So in that case, what you are doing with if answer not possible? So if answer not possible, then you are operating your R as mid minus 1, right? So R is going to become 1 and L is going to become 2, right? Now here, if you see, now you have to check why left is less than equal to right. So left is less than equal to right, no. So now in this case we have to come out of this and we have to return what, my right value. So see, this logic is working, right? We have to return 1. That's it. So let's write the code now. Okay, okay, now okay, this is done, but main part, one more part actually. So every time, right, if I say that with I'm doing the addition only, right? In this part actually what is happening if answer is possible. So how I'm going to check this answer is possible part, this is what I want to explain now. Okay, so this actually you already know, but let me tell you one more time. Okay, so here you have to just iterate over all the batteries first, and you have to calculate, do the summation of all this, and whatever this value, right, whatever this value, right? So if I'm saying t is equal to 1 minute, so only you can consume 1 minute of it, right? You can't consume more than 1, right? If I'm saying, so I'm going to take the minimum value, right? Minimum value of this 3 or the t value that I'm planning to use. So I will take minimum of this math.min, whatever minimum, right? If I'm planning t is equal to 6, then also if t is equal to 6, then definitely I can't use complete 6, I can only use 3. So that is why 3 I will get. But if t is equal to 2, some smaller value, then only 2 I will consume, right? So 3, the charging is 3, so 1 2 3, charging is 3 total, right? Charging is 3, right? So I can consume 1, I can consume 2, I can consume 3, right? But I can never consume 4 5 6 7, right? I can never consume because charging is 3 only, right? So at t is equal to 1, I at t is equal to 1, I can't consume complete 3, I can consume only 1. At t is equal to 2, I can't consume complete 3, I can only consume 2 only. At t is equal to 3, I can consume complete. At t is equal to 4, I can only consume 3 only. 5, consume 3 only. At t is equal to 6, I consume 3 only, right? So t is equal to 1 1, t is equal to 2 2, t is equal to 3 3, and after that 4 5 6, I can consume only 3, right? That's it. So this is how I'm going to check, and when I'm going to write the code, things will get more clear. Okay, but pretty much all, that's it. Here first you have to take sum is equal to 0, and then you have to iterate over all the batteries, int b, and here batteries. Okay, now here initially I was thinking of doing like this only, right? But if you want to further reduce the constants like this, here I'm taking long left is equal to 0 and right is equal to sum divided by n, so this will also work, okay? But if you take this as some smaller value, right, some smaller value, right, let's say uh, min val, okay, so you can check the mean value here, right, side by side. If you want to start from main value instead of zeros, you can also do that. So here how you are going to update math.min of uh, min val and this b value, right? This is how you can do it, okay? And here you have to create one value min val is equal to uh, integer dot max underscore value, right? So this is what you can do, right? If you don't want to take 0, right, then you can try using this. Both will work actually, okay? And here I'm going to take while loop while left is less than equal to right, and here long mid value is equal to left plus right minus left, and here divided by 2, right? So I'm going to get mid, and here I'm just going to run one if condition, if can run, okay? So here I'm just going to pass mid and I'm going to pass the batteries, right? And here I'm just going to update my left as mid plus 1, and in the else I'm going to update my right as mid minus 1, okay? And here I'm going to just simply return right. That's it, okay? So this is what we need to do, right? And now here it's a very simple if can run method we need to write, okay? So private boolean can run, and here long t, and here int n, and here int batteries, okay? And here we have to take long total is equal to 0, and here for long be in batteries, and here you have to write total is equal to total plus math dot min of b comma t, okay? This uh, t value, right, capital T, right? This is the meter that I'm passing, so based on this only I need to check, right? And here I have to return what? I have to return true na if my total value, right, is greater than or equal to the long of the number of computers I have n into t value, right? So I have to give this t to all these n, right? So that's it, okay? Now let's run the code and see if there are any code issues. We'll try to fix that. So see, all the test cases has been accepted, right? Now here if I create one more test case, let's say 2, and here let's say 1,9, okay? Now what is the output that I'm going to get? I'm going to get 1 only for this one, okay? So let's see, 1, that's it, okay? Now let's submit it. So see, our solution is accepted, right? Clear? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you, bye bye.